Welcome back to a review of my channel, my phone is called EXE. Today we're going to look at more linear functions problems. So these may vary in difficulty, some may be probably easy for you and some may be challenging. So try to solve as many as you can, and if you're struggling on a question, just continue this video and look through the solution. So anyways, this is question 1. So this graph shows a velocity time graph of a car given its velocity v meters per second, which is on the y-axis, over a period of time t seconds, which is on the x-axis. So you can observe this graph for a while. We need to find a relationship or function between v and t based on the graph. So as you notice, this is a linear function, although this is not very linear. And for part 2 or part A, we define the acceleration or deceleration of an object to be the change in velocity over a period of time. So the more the velocity changes, the more acceleration or deceleration that object has. What is the acceleration or deceleration of the car, and show how this is related to the slope of the graph. And finally, for part B, the total distance reached by the car is given by the region A, shaded in red. In here, we need to find the total distance reached by the car in this case. Let's start with part A, finding the function. Now there are two main characteristics of linear functions, which is the slope, or how fast or slow it is increasing or decreasing, and the y-intercept. And okay, we found the y-intercept here, which is 36. So assuming that we have a form of a Poinsot formula, which will be y equals mx plus 36, and 36 is our y-intercept, while m is our slope, which is unknown currently. And that's not too hard to see, because we can find these coordinates, or we can set these coordinates. So we have 6, 0, and then we have 0, 36 as our coordinates. And given 2 points, we can find the gradient of this line, sometimes called gradient or slope, by the way. So in this case, m will be the change in the x direction, which will be 6 minus 0. Oh, sorry, no. It's supposed to be the change in the y direction first, and then we have the change in the x direction. Alright, and you get a slope of -6. So the equation of this velocity time graph for this car will be y equals -6x plus 36, and in this case you can change the variables to be v and t respectively, since we're dealing with those cases based on the graph. And for the acceleration or deceleration of an object, is the change in velocity over a period of time. So assume you observe the velocities, let's say in this point and this point. So it has changed for a certain amount of velocity for a certain amount of seconds. Now this acceleration is actually equal to the slope of this graph, which is -6. So what is the acceleration or deceleration of the car? Well, first of all, it is decelerating. So I can just write deceleration of 6. Now you may be wondering, what is the units here? Well, the units of acceleration based on our definition is the change in velocity, meters per second, over a period of time per second. So here we have meters per second per second. Well, for some of you that are confused, let me just change that into 6 meters per second squared. So this is one of the units used in acceleration. So I have a distance over a period of time squared. And you will learn more about that in physics. So yeah. And show how this is related to the slope of the graph. And just like I said, the acceleration of an object is equal to the slope of the velocity time graph, in this case, which is this shape right here. So in this case, our acceleration will be the slope of the graph. So that is how it's related. And for part B, the total distance reached by the car is given by the region A. So we have region A shaded there. Find the total distance reached by the car in this case. Now you will also learn more in physics that the total distance reached by an object given a velocity time graph is actually the area bounded under the graph here. So as you can see, it is a right angle triangle. And we can determine the sides. So we're traveling here from 0, 0 to 6, 0. That is a displacement of 6 units. Same thing from here, you're traveling from 0, 0 to 0, 36. That is a displacement of 36. Once you have found your sides, you can calculate the area of the right angle triangle, which is also our distance. So distance is equal to a half times 6 times 36, which will be, let's see, 108 meters. Alright, so that is a fresh start for question 1 and jump into question 2, which I would say is pretty challenging for some of you guys. Alright, for question 2, it says that a function f map at the real numbers to a real numbers. So it accepts all real inputs x, and it will map them its corresponding input to a certain y value on the real numbers. So a function f is defined as f of x is defined as a piecewise definition. So it is 2x minus 1 for x is less than or equal to 5, and it is 5x minus 16 for x is larger than 5. So f of x has two different definitions based on the domain of x. So let's just sketch the function in a given graph. So first, let's just probably draw the first part, which is 2x minus 1. And this is valid for x is less than or equal to 5, which will mark that around there. So it will be 5. Let's just draw a imaginarily vertical line. And for the graph 2x minus 1, notice it intersects the y-axis at y equals -1. So let's just say it is around there. And it intersects the x-axis at y equals, well, you can just set y equals 0, and if you solve that equation, you'll get x is equal to 1/2. So the graph will look more or less like this. Alright, so that is the first part. And just in case if you're wondering, the coordinates of this point will be 5, 9. Alright, so that is it for the first part, which is the domain defined for x is less than or equal to 5. Now for the second part is 5x minus 16 for x is less than or equal to 5. Now if you plug in x equals 5 into this, you'll notice that it is equal to 9. So what that tells us is that f of x is actually continuous at x equals 5. So therefore, so there's no like jump off right here. So this is discontinuous. And if you call a function continuous, it means it is smooth, like so. So there's no like jump. So imagine if you're going up a hill right here, and then suddenly there's like a big ledge right here, and you have to climb all the way back top. So that is a very nice function, and it's given as 5x minus 16. However, we can just sketch it kind of like that. So this is y equals f of x. Alright, so that is pretty much all the important details for question A. Now for question B, find all coordinates of the intersection points between the graph y equals f of x, which is our drawn function, and y equals 19. Now let's suppose that is around here. Now notice that it only intersects once right here, so we're good. So let's just denote this as y equals 19. And notice that it intersects on the second half part, which is on the right hand side of the domain, which is defined for x is greater than 5, and therefore we can substitute f of x with this function since it satisfies that domain. You can also try to substitute 2x minus 1, however you'll end up with a contradiction since the corresponding x value for if you try to set this equal to f of x will give us an x value beyond this domain. So that is another way to intuitively solve this problem. Right, so let's see. So we can set f of x, which is 5x minus 16 is equal to 19. Add 16 on both sides, and then later on divide both sides by 5. So we just write that. So let's see, we will have that. So we have 35. So that means x must be equal to 7. And we can check that satisfies the domain right here. And just in case of you guys that are wondering, if you substitute 2x minus 1 and set equal to 19, you'll get x equals to 10, which is clearly not equal to or less than 5. So this x value does not satisfy this problem. And for the y coordinate of this value, you can just notice that we are already given y equals 19 there. So the only coordinate of intersection here will be 7, 19. Alright, and that's it for part B. Now for part C, we're given another function g defined at the real numbers, just like f, defined as g of x is equal to 4x intersects y equals f of x at 2 points with coordinates a, b, and c, d. Find a plus b plus c plus d. Alright, so let's just try to sketch what the graph of y equals 4x looks like. So it will look a little bit like this. Okay, so this will be y equals g of x right there. Now one obvious point of intersection is right here at the bottom. However, you might notice that this graph of g of x will not intersect with y equals f of x if you extend this way further. However, it actually intersects once. So here we indeed have 2 points of intersection, and each at different parts. So one part is on the left hand side of the domain, which is less than or equal to 5, and the other point of the intersection is located right there, the right hand side of the domain. So therefore we can just set f of x equal to g of x based on its piecewise definition of f of x. So first of all, can set 2x minus 1 to be equal to 4x, we can subtract 2x on both sides. You get negative 1 is equal to 2x. Therefore, x equals negative 1 half. Okay, and for the second point of intersection, oh wait, hold up, we need to find the y coordinate first right here, which is, well, it's not hard to see that it's equal to negative 2, since you can substitute this into either left or right hand sides of the equation. So here are the first set of coordinates of the point of intersection. So next we have 5x minus 16, we can set as equal to 4x, and you'll get x is equal to 16. And therefore, our y value will be 16 times 4, which will be equal to 64. So these are the other set of coordinates of intersection. Now we can just set this equal to a, and this equal to b, this equal to c, and this equal to d. And with this, I'll let you guys work out a plus b plus c plus d by yourself. That should be pretty simple. And that's it for question 2. Let's jump into question 3. Alright, for question 3, this shows 3 different functions f, g, and h. Function f passes to the origin and point a at 1, 6 on the plane, right here. So this is the origin and this is 1, 6. Function g passes through the origin and point b at 2, 4. And there you go. And function h passes through the origin and point c at 3, 2. And let's do part A. We need to find the equation of each functions. Now we can set each function as its Poinsot formula, since judging on the graph, we know that each function are linear. So for function f of x, we can set it to be mx plus the y-intercept. However, all of the functions intersect the y-axis at y equals 0, since it intersects on the origin. So we need to add the plus b term. So we need to find m right there. So the gradient of the function f of x is not too hard to see, but it is equal to the displacement, the change in the y-axis, or the change in the y-coordinates, if you were to say that, over change in the x-axis, and that will be equal to 6. So this function f of x is defined as 6x. Again, the same for g of x and h of x. So let's just name this other letters except m. So of n and l. So of m and l. So the gradient for g of x is equal to the displacement in the y-axis, which will be 4 over 2, which will be 2. So this is defined as 2x. While on the other hand, the slope for the graph h of x is equal to, let's see, 2 over 3. And you can really simplify that, so we can just do that. Alright, so here are the answers there and the equations. Alright, for part B, it says a line L with the equation y equals 3 is drawn on the same plane. Or should I rather just draw the line L right there? So it's y equals 3. So as you can see, there are 3 points of intersection between line L, I'll just put it on there, and each of f, g, and h. So we need to find the coordinates of those points. First, we can set y equals 3 into the function f of x. So let's see, we can have y is equal to f of x. It's equal to 3, and based on the definition of f of x, we have 6 of x. And that gives us x is equal to 1/2. And this is also pretty obvious that the y value is equal to 3. We can do the same. We can set y is equal to g of x in this case. It's equal to 3, is equal to 2x. And therefore, x will be 3 over 2, while the y will be still the same. And finally, we can set y equals 8 of x is equal to 3, is equal to 2 over 3x. Therefore, x is equal to 9 over 2, and therefore y is equal to 3. So these are the coordinates of intersection between line L and each of the 3 functions above. For part C, let me just write, see there, a line M with the equation x equals 4, which will be, let's see, around here, I guess. Keep in mind this is not to scale. So this equals x equals 4, and this is line M. We need to find all coordinates of the intersection points between the line M and the functions L. So notice this intersects once, H intersects once, G and F. If you extend M, F, and G, it will intersect each exactly once at a certain point. So let's see, we can set, let me just denote this operation as the intersection point between function L and M. And later I will write something like f comma m, which indicates the intersection point between function f and line M. So for the first intersection point, which is between L and M, it is not hard to see that it's equal to 4, 3. Okay, and let's see, for h comma m, that will be equal to, I'll just put a arrow there. We can set h of x, and then we can just input x equals 4, since we know the equation of the line is equal to x equals 4, which is equal to 2 thirds times 4, so be 8 thirds. And therefore, the coordinates of intersection will be 4, 8 over 3. Notice that this result is the y value produced by h of x. Next, we have g comma m, and then later on f comma m. So I can set g of x, inputting x equals 4. We have 2 times 4, which is equal to 8. Therefore, our coordinates of the intersection will be 4, 8. And finally, we can set f of x, and then inputting x equals 4. That will give us 6 times 4, which is 24. And therefore, the coordinates of intersection will be 4, 24. So these are the results. So 4, 3, 4, 8 over 3, 4, 8, and 4, 24. Alright, so that's it for question 3. I shall move to the question 4, which is the last question. Alright, for the final question, question 4, a function u of x is defined as u of x to be x for x is less than or equal to 1. And again, you may guess that this is a piecewise definition of a function. And it is defined as negative x plus 2 for x is greater than or equal to 1. We need to find the coordinates of the maximum point of the function, the coordinates of intersection between y equals u of x and y equals -2, and the coordinates of intersection between the graphs y equals u of x and y equals 2x minus 1. And first, let me start by drawing the graph of u of x in this plane that I've drawn. So let's just separate this plane into two different boundaries based on the domain of the function u of x. So this is at x equals 1. So for the left hand side, we can draw the first definition of u of x, and for the right hand side of this region, we can draw the second definition of u of x. For the first part, u of x equals x, well, that is at least pretty simple. We can just draw a diagonal-ish line right there. So it hits this point at 1, 1. Alright, and if you plug in x equals 1 to both x and -x plus 2, you'll end up with the same value, which is 1. And that tells us that u of x is continuous at x equals 1. And that's just a bit of information. We can just draw -x plus 2, which will look a little bit like this. Let me just draw this correctly. Yep. So it will intersect this point at x equals 2, and then it will extend downwards. Now you may guess that the maximum point of the function is indeed 1, 1, because notice that if you were to go this way, you end up going downwards and ending up decreasing the value of y. And on the other hand, if you decide to go to the right hand side, you end up yet again decreasing based on the graph of -x plus 2. And forget to indicate this y equals u of x. So indeed, we have shown that the maximum point is at 1, 1. So this is answer for part A. Now for part B, we need to draw y equals -2 on the same graph. So it will look a little bit like this. Y equals -2. And notice it intersects at 2 points right here. And notice that these points of intersection occurs at two different regions. One is the region on the left hand side of this imaginary vertical line right here, and one point of intersection is on the right hand side. So what that tells us is that we can set its definition of u of x to be equal to -2 to find both points of intersection. So I can set u of x is equal to -2, and based on the first definition, it is equal to equal to x. Well, this is pretty obvious. This x equals -2, so that means our coordinates of intersection will be -2, -2. Since its y coordinate will be -2, it's shown there. We can do the same, but in this time, we're going to use the other definition, which will be -x plus 2, and you end up with x equal to 4, and therefore our coordinates will be 4, -2. So these are the answers for part B. And for part C, find all possible coordinates of intersection between the graphs blah 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 and y equals 2x minus 1, which I'll just draw something. Let's just draw something like this. So it is a graph like that. Alright, you may infer that this will only intersect once here, and you may confirm by trying to substitute u of x, the two definitions of u of x, and see which one works. I'm going to start with the first definition, which is u of x equal to x. So we can set 2x minus 1 is equal to u of x is equal to x. Alright, from here we can get that x is equal to 1. and therefore our coordinates of the intersection in this case will be 1 comma, let's see, yep, it's 1 comma 1, you guessed it. And notice, although this is not really drawn to scale, but the point of intersection should be on this point right there. Although this might be a little bit more confusing, to be honest, but just assume that it's not drawn to scale. Right, so this is y equals to x minus 1. So it intersects at the maximum point right there. And you may also check that no other points of intersection will work, but try to plug in the other definition of u of x. So that will be 2x minus 1 is equal to negative x plus 2. You'll get 3x is equal to 3. It will be x equals 1, which we have ended up with the same conclusion. So therefore there's only one point of intersection, which is at 1 comma 1. Alright, and that is it for question 4 as well as this video. So hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next video. Goodbye.